If you are a business owner or someone who watches a lot of YouTube videos, then you will appreciate the YouTube MCP server I am about to share to be used with Claude Desktop in this video. Now, as a full-time content creator and developer, I'm always hitting up YouTube for the latest tech news, product demos, and to audit my channel's content. The tools in the YouTube MCP server have pretty much streamlined at least 80% of my workflows, and I'm pretty sure you will find many uses as well. Here, let me give you a quick demo to show you some of the things the YouTube MCP server can do. MKBHD being one of the largest tech product review channels on YouTube. Let's say I want to check out the last 5 videos released from the channel. In Claude Desktop, I can simply say return the last 5 videos released by MKBHD. Based on my request, Claude will first use the search channel tool to get the channel ID, then use a different YouTube tool to get the last 5 videos published from the channel. I see that the Apple's AI Crisis Explained video is almost 17 minutes long. Here, I can ask Claude to summarize the video for me instead of watching the entire video. And based on the video transcript downloaded, we can quickly get a complete video summary. Another use case is we can tell Claude to return all the links found in a video description. And it also works if you give Claude multiple videos IDs. Before I dive into how to set up the YouTube MCP server, make sure you have both Python and Claude Desktop installed on your PC. The great thing about the YouTube MCP server is that it works even if you're on Claude's free tier. So no need to be a paid Claude user. You can still use the MCP server to automate your YouTube tasks right in Claude Desktop. And if you are new to MCP, you can watch my video on how to set up an MCP server in Python. I just want to clarify that this isn't a tutorial video. It's more of a walkthrough to show you how to set up and run a YouTube MCP server with Claude Desktop. This gives Claude models YouTube tools, so they can run tasks like summarizing a YouTube video, pulling video descriptions, or searching channels and videos on YouTube. One major benefit is that it's a great alternative to the web search tool, adding context to deliver more polished and accurate responses. And even if you are not a technical person, you can install Python first, type the script, and follow the steps that I'm about to go through in the video. To create the YouTube MCP server, first we need to set up YouTube API access in Google Cloud Console. To set up YouTube API in Google Cloud, navigate to console.cloud.google.com. If you don't have an account, sign up for an account first. It is completely free. In the Google Cloud Console, look for the project dropdown at the top of the page and click on it. Then select New Project if you don't have a Google Cloud project created. Give your project a name and click Create. Once the project is created, select the project. To enable YouTube API, navigate to APIs and Services and click Library. Search for YouTube Data API. Click YouTube Data API v3 and enable the API. The YouTube Data API is free to use with a daily quota of 10,000 units. Under Quotas and System Limits, the Queries per Day quota type will display how much quota you have left for the day. And different operations cost different amounts of quota. The search list operation costs 100 quota usage per request compared to the regular list operations. Just keep that in mind. Next, we need to set up the OAuth consent screen. Under APIs and Services, select OAuth consent screen. click Get Started. Give the app a name and go through the steps to set up the app. For the audience type, choose External. Now we need to add users who will have access to the project. In the panel menu, select Audience. In Test Users, select Add Users and add the users who will have access to the project. Now that we have finished setting up the OAuth consent screen, the last step is to create an OAuth client account to generate the credentials needed for your application to access the YouTube Data API. In the panel menu, select Clients. Click Create Credentials at the top and select OAuth Client ID. For the application type, select Desktop App. Give the client ID a name and click Create. Download the client file in your project directory and name the client file clientsecret.json. At this point, we are done setting up YouTube API access in Google Cloud Console. Now we can dive into the YouTube MCP Server development in Python. To start with the development, launch a terminal pointing to the project directory and run the command to install MCP, Rich, YouTube Transcript, and Google API Python libraries. In your project directory, create a folder called Tools. This will be the directory to store all the tool modules. To organize the tool modules, in the Tools directory, create a folder called Google to store Google API specific modules like Google Sheets, Google Calendar, Gmail, and YouTube. In the Google directory, create 3 Python files, init.py, Google APIs.py, and YouTube tools.py. Open the Google APIs.py file. In the script, import the Python dependencies and create a function called createService, as I'm showing on the screen here. The createService function is used to create a Google API service instance like Gmail, Google Sheets, YouTube, or other Google products. In the function, assign the input parameters to constants for better readability. For the scopes parameter, convert it into a list using list comprehension. And the rest of the code are basically generating a reusable token file and construct a Google API service instance. Now open the YouTube tool.py file. And this will be the module with all the YouTube tools. Again, start out by importing the Python dependencies and the createService function from Google API's module. Next, create the data classes to define the data model for the record from the API output based on Pydantic's base model. And here I forgot to include data model for the video results. To extract YouTube video ID from a URL or ID string, create a function called extract video ID with input string parameter. In the function, first define what the function does using a docstring. The docstring explains that the function extracts YouTube video IDs from URLs or ID strings, lists the argument as input string, and specifies the return value as the extracted YouTube video ID. With the regular expression module, create a URL pattern that matches common YouTube URL formats. For the first check, use the match method on the URL pattern to see if the input string matches a YouTube URL. If there is a match, return the first capture group, which contains the 11-character video ID. If the first pattern check failed, create a second pattern for direct video IDs. This pattern simply checks if the input string consists of exactly 11 characters that could be a valid YouTube ID. For the second check, if the input string matches the ID pattern directly, return the input string itself, since it's already a valid video ID. At the end of the function, if neither pattern matches, return none to indicate no valid YouTube video ID was found. Now create a class called YouTube tool with client secret parameter. We are going to use the YouTube tool class to manage the YouTube tool functions. With class variables, define the API name as YouTube, API version as v3, and set the scopes list to include the YouTube read-only authentication scope. For the initialization method, accept the client secret string parameter and store it as an instance variable. Then immediately call the private init YouTube service method. Inside the init method, initialize the YouTube data API service by calling the create service function with the client secret API name, API version, and scopes as parameters. If the service creation fails, raise an exception with an error message. The YouTube service property returns the YouTube service instance in case if you need to reference the service object directly. To retrieve YouTube channel information, create a function called getChannelInfo with channel ID parameter. In the function, confirm the format of the provided channel ID. For channel IDs starting with UC, create a request to the YouTube API channels list endpoint with snippet and statistics parts, passing the ID directly. With channel handles starting with the @ symbol, create a similar request but use the forHandle parameter instead. For any other format, return an invalid channel ID message. After creating the request, execute it to obtain the response from the API. From the response, extract various channel details, including the channel ID, channel title, description, publish at date, country, view count, subscriber count, and video count. Inside the response processing, use the get method when accessing dictionary values to prevent key error exceptions if certain fields are missing. For nested data like snippet and statistics information, navigate through the response structure carefully to extract each required piece of information. With all the channel data collected, create a channel info object containing all these properties. Finally, return the JSON representation of the channel info by calling model.dump.json on the object. The function handles both standard channel IDs and channel handles, making it versatile for different identification formats on YouTube. As we go through the rest of the functions, you will notice that all the functions are set up almost the same way, except the API endpoint. To search for YouTube channels, create a function called searchChannel with channel name as required parameter, along with optional parameters for filtering results by date ranges, region code, order, and max results. In the function, initialize an empty list to store channel results, set total results to 0, and initialize next page token as none. Within a while loop, calculate the current maximum results needed for each API call by comparing 50 with the remaining results needed. For the API request, use the YouTube service object to call the search list method. With the parameters, specify a snippet as the part, the channel name as the query, channel as the type, and include other search parameters like max results, order, date filters, region code, and page token. After executing the request, loop through each item in the response. From each item, extract the channel ID, title, description, and publish date. Then create a channel info object with these details and append it to the results list. Outside the item loop, update the total results count from the page info and get the next page token. If no next page token exists, break out of the while loop. Finally, return the channel results as a JSON string, including the total count and the list of channels found. To search a YouTube playlist, create a method called search playlist with query as a required parameter and optional parameters, including published after, published before, region code, order, and max results. The implementation is almost the same as the search channel method, except here we are calling the search list API endpoint. And here's the rest of the function. Finally, return the results wrapped in a playlist results object converted to JSON format using the model dump JSON method. And to search videos, create a method called search videos. The video implementation is identical to the search playlist method, except the API endpoint is different. And here's the rest of the function. To retrieve information from YouTube videos, create a function called getVideoInfo with parameters video IDs and max results. This is probably one of the most useful functions in the class if you do a lot of SEO analysis or content research. In the function signature, define the required parameter video IDs as a string type that accepts comma-separated video IDs. With the optional parameter max results, provide a default value of 50. Inside the function, add validation logic for handling single video IDs. If the length of video IDs is 1, process it through the extract video ID helper function. When the extraction fails, return an error message about invalid video ID or URL. Initialize an empty list to store video results and set the total results counter to 0. For pagination handling, set the next page token to none initially. Start a while loop that continues until the list reaches the requested maximum results. On each iteration, calculate the current maximum batch size as either 50 or the remaining number needed. In the request preparation, create a videos list request to the YouTube API with comprehensive pod parameters. For the pod parameter, specify multiple components, including ID, snippet, content details, statistics, paid product placement details, and topic details to retrieve complete video information. With the video IDs passed to the request, execute it and store the response for processing. For each item returned in the response, extract detailed information from different sections. In the last step, return the results as video results object in JSON string. To retrieve videos uploaded by a YouTube channel, create a function called getChannelVideos with parameters, including channel ID and max results. On each iteration, prepare a request to the channel's endpoint of the YouTube API. Before making the playlist request, calculate the current maximum results needed. Take the minimum value between 50 and the difference between max results and current list length to avoid fetching more videos than necessary. With the uploads playlist ID, create a playlist items request to fetch video details. Once all videos are collected or the maximum limit is reached, return the result as video results object in JSON string. Moving on to the last function. To create or proper YouTube links from YouTube resource IDs, create a function called Construct Hyperlink with ID and type parameters. In the function definition, specify both parameters as string type, with the return type also defined as string for the generated URL. Inside the function, implement conditional logic to handle different YouTube resource types. For channel resources, format the link using the YouTube channel URL pattern followed by the provide ID. After constructing the appropriate link based on the resource type, return the complete URL string. And that completes the YouTube tool module. Now open the init file in the Google directory. In the file, type the import statement like what I have here. The purpose of the import statement is that it converts the Google directory into an intermediate module. So when we import the YouTube tool module, we don't need to specify the file name. At this point, we are officially done with the YouTube tool module. The next step is to set up the MCP server with the YouTube tools. In the project directory, create a Python file. Let's call it MCP YouTube server.py. In the script, import the Python dependencies. The FastMCP class serves as the main interface for creating model context protocol servers in Python. It provides a high-level Pythonic way to build MCP servers that expose resources, tools, and prompts to models like Claude, Gemini, or GPT. Next, create a FastMCP object with the server name and specify the third-party Python libraries the server needs to use. Now create a YouTube tool object with the client's secret file as argument. Then use the MCP add tool method to add the YouTube functions from the YouTube tool object. Here I forgot to include the extract video ID function. Let's go back to the top and import the function. And in the init file, we need to add the function as well. All right, let's add the extract video ID function to the MCP server as well. Now, because the YouTube video transcript download function is not part of the YouTube tool class, we are going to create the function separately in the MCP server file. Create the download transcript function with video ID and include timestamp as parameters like what I have here. And in the last step, insert the main routine to launch the server. Now here, let me remove the existing YouTube MCP server in my Claude Desktop. Open your terminal and make sure the current directory is pointing to the project directory. To add an MCP server to Claude Desktop, run the command mcp install, followed by the MCP Python file. During the installation, it's going to prompt you to log into your Google account. Log into your account and grant permission to the app. In your project directory, you will notice that a folder called token files is created. And inside the folder, you will see a token file generated. And that's the YouTube API authentication session that can be reused across multiple scripts or applications to authenticate and interact with the YouTube API without needing to reauthorize each time, as long as the token remains valid and unexpired. And if you need to use a different account, simply delete the token file and reauthenticate. Now open your Claude Desktop. On the top, go to File, then Settings. If you set up and typed everything correctly in the Developer panel, you should see the YouTube server is now available and running. Now in the prompt, I can give Claude a request. Return the last 10 videos released by OpenAI YouTube channel. And Claude will choose the appropriate functions from the YouTube MCP server to complete the task. One last test. Summarize the video how ProTopica used Remix and Blend in Sora. And the download YouTube video transcript function will be called. And here's the summary of the video. And that's it. That's basically how to set up YouTube MCP server from scratch to be used with Claude Desktop. I hope you find the video useful. If there are any tutorial ideas you have in mind and you would like me to cover, please leave them in the comments below. And also don't forget to like the video and subscribe. Happy coding. See you in the next one.